So we have a set of odd integers, and we know about two of the terms in this set. The question wants to know whether or not negative 15 is in the set. Now, I think it's relatively easy to see that neither statement is sufficient on its own in this case. Let's just go through that fairly quickly. So statement 1 gives us one more odd number in the set, but we still don't know whether negative 15 is in there. It may or may not be. And statement 2 tells us that anytime you have two numbers in the set, the product of those two numbers is also in the set. But so far, all we know that the set has is 3 and negative 1. So we could infer that negative 3 is in the set, because that's the product of 3 and negative 1. And now that we know that negative 3 is in the set, and 3 is in the set, and negative 1 is in the set, all of the products of those things would also be in the set. So you'd have 9, negative 9, 27, negative 27. We can keep multiplying by 3. So basically, it would be an infinitely large set that has all of the powers of 3, both on the positive side of the number line and the negative side of the number line. But I wanted to know about the number negative 15, and that's not a power of 3, right? So I still don't know whether negative 15 is in the set. It may or may not be. Now, if we combine these two statements, we see that we have negative 1, we have 3, we have 5, and we know that the product of any pairs of numbers in the set is there as well. Is negative 15 a product of two of the numbers in the set? Yeah, it sure is. So combined, we can answer the question, and therefore the correct answer is C.
If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.